Welcome to Techno Sapiens.
Welcome to the Explainer. So, have you ever just looked up at the sky, seen those absolutely massive high-voltage power lines stretching out toward the horizon, and wondered about the terrifying mystery literally hiding in plain sight? Like, why is all that incredible, lethal electricity flowing through completely bare, exposed metal wires? Today, we're unraveling the invisible engineering that surrounds us, and trust me, it is fascinating. Okay, let's dive right into this. Think about your everyday life for a second. Your phone charger cable, covered in plastic. The wires running through the walls of your house, all wrapped up in colorful plastic. We're totally conditioned to believe that electricity has to be securely wrapped up to be safe, right? So, why on earth aren't the giant power lines, the ones carrying thousands upon thousands of volts directly over our heads, covered in that exact same protective layer?
Think about a standard household cable. It's safe, heavily padded, something a child could theoretically touch without harm because all that electricity is trapped securely inside. But compare that to a high-voltage transmission line. It is nothing but completely bare metal. It's carrying enough raw power to run an entire city, yet it lacks any visible protective wrapping whatsoever. Why does the significantly more dangerous wire get literally zero visible protection? To really get this, we need to quickly look at what insulation actually is. Simply put, it's an electrical barrier. Its whole job is to keep the electric current trapped inside the conductor, usually copper or aluminum, and physically prevent those electrons from escaping sideways into nearby people, animals, or objects. Basically, it stops you from becoming part of the electrical circuit. But insulating a tiny house wire is a completely different universe of physics compared to a giant transmission line. Let's start scaling things up a bit. Inside your house, your standard electrical outlets operate at a relatively low voltage. In a lot of the world, that's right around 230 volts. A millimeter or two of standard plastic is completely sufficient to hold that energy back, no problem at all. But once we leave your house and head to the power lines on your local street, things change rapidly. We jump to 11,000 volts. The stakes are definitely getting higher here. The electric field around the wire is expanding and pushing a whole lot harder against its boundaries. Now, move to the larger regional transmission lines, and we skyrocket to 132,000 volts. The sheer electrical stress pulsing through these metal conductors is just phenomenal. It's almost hard to even wrap your head around. And then, we hit the massive cross-country grid transmission lines operating at an earth-shattering 400,000 volts. This is a terrifying lethal leap in power. At this extreme level, electricity absolutely does not behave like that tame little current in your phone charger. The electrical field expanding outward from this wire is violently powerful. This kind of raw energy kills instantly, and it pushes against standard plastic insulation so aggressively that a thin layer would literally be vaporized in a flash. Now, what's really interesting about this is that it all points to one core physical rule. Higher voltage absolutely demands greater insulation requirements. To safely insulate a 400,000 volt transmission line, a simple plastic sleeve is utterly useless. The insulation would need to be massively thick and specially engineered out of highly advanced materials just to withstand that immense continuous electrical stress without breaking down. So, let's do a little thought experiment. Imagine we actually tried to wrap our entire national power grid in this specialized, massively thick plastic. First off, the material cost would be astronomical, just to cover thousands of kilometers. Second, that extra thick insulation adds colossal weight. The cables would sag dangerously toward the ground. And to fix that sagging, engineers would have to build significantly taller, heavier, and way more expensive metal transmission towers everywhere. And hey, even if we did all that, these wires live outside for decades. The sun's UV rays, freezing rain, pollution, wildly fluctuating temperatures, it would constantly degrade the plastic. It would crack, creating lethal weak points everywhere. The whole system would just completely collapse.
So, how do engineers solve this seemingly impossible problem? Well, they look to the invisible: air. Power lines don't actually need plastic insulation because the air around them naturally acts as an electrical insulator. Air generally resists the flow of electricity. It is a completely free, weightless, self-healing material that perfectly surrounds the wire. Pretty genius, right?
But air alone isn't quite enough. It needs a partner, and that partner is distance. Instead of surrounding the wire with a physical, solid barrier, engineers just use empty space. By simply keeping the wires very far apart from each other and incredibly high above the ground, they create an enormous, invisible safety buffer.
Of course, the wire still has to physically touch the metal tower to be held up in the air. So how does the electricity not just travel down the tower and electrocute anyone who touches it? Well, the power line flows through a conductor, but right before it reaches the tower, it connects to specially designed massive string insulators. These are usually made of glass, ceramic, or advanced composites. These brilliantly engineered bottlenecks support the staggering weight of the power lines while completely blocking the electricity from flowing into the grounded metal tower.
This all sounds like a perfect setup, right? Free air, super tall towers, sturdy glass insulators. But this brings up a rather chilling question. Is air a perfect insulator? The terrifying answer is no, not at all. And this is exactly why high voltage power is incredibly lethal.
So the crucial point is this. When voltage gets high enough, it creates an electric field so incredibly strong that it literally rips the surrounding air molecules apart. It energizes them, splitting them into ions and free electrons. In an instant, the invisible air, which normally protects us, is violently transformed into a highly conductive, lethal pathway for electricity.
This crazy phenomenon results in an electrical arc, and this is exactly why power lines kill instantly without you even having to touch them. Think about that. If a tree, a ladder, or a person gets too close, the immense electrical field ionizes that gap of air. The electricity will violently arc across the empty space, using the object or person as a direct path to the ground, dumping lethal current through them in a fraction of a second. This bright, deadly discharge is the exact reason massive safety distances are not just suggestions, they are absolute, mandatory physics.
You can clearly see this physical constraint in action when we look at underground cables. When engineers are forced to bury power lines, they completely lose that luxury of open air and safe distance. Because the cable is surrounded by highly conductive earth, they have absolutely no choice but to wrap those underground lines in those incredibly heavy, highly expensive engineered layers of solid plastic shielding we talked about earlier. It is a massive, massive undertaking compared to just stringing wires up on the sky.
And this brilliantly illustrates the entire invisible engineering marvel hanging right above our heads. Let's recap real quick. If we tried to use solid insulation for high voltage, it would need to be massively thick, which adds unbearable weights and astronomical construction costs. So instead, engineers use the air around us as a natural, invisible insulator, combining it with clever glass and ceramic insulators and sheer physical distance to achieve completely safe separation.
But I do want to leave you with a very grave warning here. Because this system relies entirely on distance to keep you safe, a fallen power line is a catastrophic failure of that safety system. A downed high-voltage wire might look quiet, but it can still be heavily energized. Worse, that lethal electricity instantly spreads outwards through the ground in invisible danger rings. Literally, walking anywhere near a fallen line can kill you instantly because the ground itself becomes part of the electrical circuit. Seriously, never approach it. Maintain an immense distance.
The power grid is just a stunning marvel of working alongside the laws of nature rather than fighting them. By utilizing the empty sky, we power our entire civilization. So the next time you look up at those towering metal giants and bare wires, what are you going to see? Just empty space? Or will you see the invisible, vital boundaries of smart engineering, suspended in the air, silently keeping you safe? Keep observing, keep questioning, and we'll see you in the next explainer.